Welcome, everybody. We are officially kicking off session number 4 of the 2020 Mid-Atlantic Chasercon today. And we're just excited to have our Chaser panel, which we'll introduce to each one of them to you in a little bit. But, obviously we're not in person this year like we were the last 2 years, but virtually we've been able to do some pretty cool things, and we appreciate the technology here. But let me just kick it over to our co-host today. And not only has Brent been the co-host for the first session and the last session, he's been pushing all the buttons, the technology buttons for us for each session. So I really appreciate that. So let me introduce the Chief Meteorologist of WDBJ7 here in Roanoke, Brent Watts.
Chris, thank you so much. It's a pleasure to be with everybody again this week. And what a great couple weeks we've had with the virtual Chasercon. So glad everybody was able to join in. And of course, if you missed a couple weeks, previous, so we've had some great speakers on. We'll talk about how you can check that out in a little bit and some of those speakers. But it's great to be with you. Storm chasers are so critical when it comes to telling a TV story, especially when there's severe weather. And we have 3 great chasers that are also very knowledgeable in their field as well. We're going to start out today with our first chaser. This is Chris Jackson. Chris has spoken before at Mid-Atlantic Chasercon. He's a chaser with Live Storms Media, has been chasing since 2014, has a really just a long background of storms that he's been chasing, not only, severe thunderstorms, but hurricanes and all kinds of stuff. Is also an aviation photographer, which I find fascinating, and grew curious to weather after Hurricane Hugo in 1989, which is one of the ones I remember as well growing up here in Southwest Virginia. In fact, one of the few tropical storms that actually was still holding together when it moved through Virginia. So we're going to head over to Chris Jackson today. Chris, thanks so much for joining, and I'll let you share the screen, sir.
I appreciate you guys for having me, Brent, Chris, and it's good to be here again. And this is year number 2, so maybe we can make this a yearly thing, continue to make it a yearly thing. But without further, I'll get right into this thing. What I'm going to share today is some of my, experiences from the April 13th, 2020 tornado outbreak here in South Carolina. It was South Carolina's single deadliest tornado event. And I was out chasing early that morning. All the tornadoes were nocturnal, and really learned some interesting things that I'll cover here. But about me, just like Brent said, I've been chasing storms since about 2014. 2018, I started to feel comfortable enough to, go about anywhere in the country and chase any kind of storm there is. Born and raised in South Carolina, just outside of Columbia. I actually grew up on a farm, about 1,000 acres, 200 cows, that kind of deal. I was a professional firefighter for 15 years. I was a member of the South Carolina Urban Search and Rescue Task Force. I'm a nationally accredited swiftwater rescue instructor, nationally certified fire instructor. And as Brent said, I'm down chasing storms with Live Storms Media, and also doing aviation photography full time, and also doing a little blogging on Facebook. I'm the owner of South Carolina Weather on Facebook, and I got my social links on there if anybody wants to follow me, by all means. All right, so about April 13th, it's a storm chase in a period of 3 days afterwards that shoot damage I'll never forget. Our state was just ravaged. We had the most significant tornadoes reported in one day. We had 12 tornadoes just in South Carolina in a 24-hour period. That was EF2 or greater, and with 7 EF3s and 1 EF4. Unfortunately, there was 9 fatalities in this event. And it was the first F4 EF4 since 1995, really since the enhanced Fujita scale became a thing. And it was the first EF3 tornado we'd seen in South Carolina since 2009. The setup on that day was crazy. For a lot of folks that are really weather weenies and meteorologists alike, most people understand what was going on here. But there was a huge negatively tilted trough over the Midwest with a cutoff area, low pressure in the mid levels. And as this progressed eastward, it helped to really kick off a surface low explosively, which allowed for a better return flow of moisture and theta E off the Gulf with dew points all into the southeast of 70 degrees or greater. That was also aided by an anomalously warm Gulf of Mexico, which temps in the Gulf of Mexico at the time were 1 to 3 degrees Celsius above average. And combine that with some of the divergent flow from the upper level jet stream and the cold air helped to create a differential temperature advection. There we go. Sorry. And going into some of the soundings from that day, The soundings that you were seeing, especially across the entire suite of models, were apocalyptic. It's like, everybody jokes on weather Twitter about, what's going to happen, cherry picking, soundings and stuff like that. But this is actually a stress sounding. So it's an ensemble sounding. And this is kind of what I was seeing for almost 2 days leading up to the event. I mean, it just wasn't stopping at all. And just for reference, this is for 05Z, and this verified 38 hours within about an hour or so. Or 38 hours within about an hour or so. So pretty remarkable to see the good model consensus, which helped folks at the National Weather Service and also broadcast media be able to really relay the message a lot better. All right, so what did I do? My timeline of events. So knowing this was going to be a high impact event, what I did was I adjusted my sleep schedule 2 days in advance, and 2 days in advance to try to be awake, well rested, and have the cognitive ability to make good decisions. Because anybody that chases in the Southeast and Mid-Atlantic knows, with the road network, trees, and everything else, sometimes one mistake can be the only mistake that's needed for something bad truly to happen. And I try to limit that as much as possible. As the storms approached, left home about 3:20 in the morning as a QLCS was pushing through the Macon, Georgia area. Identified a storm really early on that was literally just maybe 5 miles south of downtown Macon. And it was just a beast on radar, looking at it from the Warner Robins site in Georgia. And my game plan was just to head west from Columbia down I-20. It's about a 60-mile drive. Made it down there in about an hour or so. And it sat at the corner of Interstate 520 on the off-ramp to U.S. Highway 1, which is the Aiken-Augusta Highway. And for those that are not familiar, that little area right there is a really high bluff that overlooks the entire city of Augusta. It's actually beautiful in the daytime. And so my thought process was I could just sit here and just wait for storms to come to me. And that's exactly what I did. It took about 20 minutes. I was hoping I'd be able to make out some kind of base structure, that kind of deal with some of the lightning flashes, but that just didn't happen because of the tremendously heavy rainfall. As the storm really began to approach the Savannah River, I knew I was only going to have one shot at the storm, so I had to start making my move right as the storm was approaching the river so I could be in position to where I wanted to be. And one of the things that was really difficult about this chase was this little facility in South Carolina that maybe not a lot of people are familiar with, called the Savannah River site. It's about, I think it's 360 square miles. My dad actually retired from out there, but they're a nuclear weapons facility that built nuclear weapons for the government all the way, right past the Manhattan Project in the 50s, all the way up through the late 70s until they started decommissioning the nuclear reactors in the 80s. But that entire area is just surrounded like in a semicircle, half moon, by a perimeter fence and 100-foot tall pine trees. This is the road I was chasing on that morning. It just, everybody talks about the jungle. This is the jungle. You can't see anything. There's no way to see anything. So if you're chasing, you have to be extra careful, because if you get in front of a storm or if you get in a position to where you can't see what's coming, things can go really bad really fast. What happened with this as I approached the storm? I'm going to go back to this GIF right here because really. All right. Anyways, there we go. As I approached the storm, I actually fell in right behind it as it passed by me. And at its closest, I was maybe 500 yards from it. I've got some video that I was going to share a lot of it, but it would take so long to do it. I felt in the best interest of time, probably wouldn't be the best place to share it. Maybe I'll upload it to YouTube at some point. But there was full-size pine trees falling out of the sky in front of me, and big power flashes happening along with lightning. I was actually able to get one glimpse of the tornado in my dash cam, and it got like 6 frames of it in a lightning flash. As soon as I come upon that, there was trees all across the road, and the chase was obviously over. At that point, I was just concerned with any kind of life safety or helping anybody out. But my first contact was to the National Weather Service, where I called John Q. He's one of the Warner Coordination Meteorologists there, I believe, and I told him what was going on and stuff, and he upped the warning on to a confirmed dangerous tornado, all the things. And they were actually getting ready to drop a tornado emergency as this storm began to approach some towns, but the tornado thankfully dissipated before it got to that point. some of the pictures I took that morning, this is a stop sign directly beyond a house. And the house I'm going to cover a little bit here in a minute with some video I took. But it's a stop sign that was just bent over by the wind, and some T-posts. The T-posts are really interesting. I don't know if you've ever messed with fencing or T-posts or anything like that, but they're a pretty solid little piece of metal. So you start bending a T-post like that, you know you got something really strong happening. And again, this is in the foreground here. I'm sharing this is a building that was just absolutely flattened. Granted, it was a masonry construction building that didn't have any reinforced concrete, inside the walls between the blocks, but it was still it was almost swept clean. And this is near where the tornado dissipated further on down the line. This tornado was actually on the ground for 22 miles and interacted with another EF3 tornado that formed just about 5 miles to my south. As the tornado was crossing the road right in front of me, there was actually 2 tornadoes on the ground, and they mirrored each other for about 25 minutes. And as they got to the end of their life cycle, I believe one tornado was ingested or came into the circulation of another tornado and almost did a Fujiwara-like effect where one tornado spins around the parent, and they both ended up decaying shortly thereafter. But this is the town of Nices. I believe there was 2 fatalities here, which is you hate to see. With that, I'm going to let's see here. Here we go. The house. I was mentioning to you guys a house here. Let's see. There we go. Hopefully you guys can see this, but this house right here was directly on Williston Road, which was the road I was chasing on. And right after I got off the phone with the National Weather Service, I started trying to make my way through the pine trees and stuff. I was literally jumping pine trees with my truck. And I could make out the house within the lightning flashes. And I pulled up to the front of the house, and I started seeing a faint flashlight hit the window. And so the moment I did that, I faced my truck in the driveway, just facing toward the porch. And I grabbed my go bag that I keep for my days as a firefighter. It's got medical supplies and stuff like that, and just started going into render A and actually pulled up an older, I ain't gonna say elderly, but older couple out of their home. They sustained some minor injuries. And one of the most crazy things that happened that morning, after I kind of had to sort of give the door some motivation to open with my foot because the house was racked and wouldn't open, the woman immediately recognized me from Facebook because she follows my weather page, and she had for a period of like 3 years, I believe she said. And she called me by my name, and I was absolutely blown away. Like that was even as a professional firefighter, you try to not make it personal, but she made it really personal that morning. And so being able to be there and really help her and her husband was emotionally interesting. How about that? I was not expecting that, but that's why I'm out there trying to do everything I can to help out anybody in need. But their house was almost half gone. Their bedroom was actually in the back corner right here that's half missing. They had taken shelter in a closet in the hallway. And here's another video of that building that was turned into a slab, for lack of better words. But the damage was just, from this tornado, it was bad. Don't get me wrong. But this is not where my chase ends for this day, because later on that day, I found myself down in the, whoops. Let's try this one more time. Later that day, I found myself down in the town of Estill, which is down in southern South Carolina. I had no clue this tornado had even happened. I started getting text messages from friends with just nothing but a screen share of like a radar image, and like the velocity couplet and the reflectivity signature was I thought it was fake at first. I didn't want to believe it. But anyways, I headed down there and started shooting video, and I was there before anybody was. Some of the people down there said I was the first person they ever saw, and that was pretty interesting also. All right, let me see what's going on here. I'm trying to share one more thing here. Alrighty then. Let's try this one more time. Gotta love technology. Wow. Huh. All right, so Zoom obviously does not want me to share this video, but what I can do is I can put it on YouTube and I'll shoot a link on my Twitter page or something. Anybody watching, I'll let you guys see. Long story short, EF4 tornado down there. I think there was at least 5 fatalities down there, and I believe an entire family was fatally injured when their double wide mobile home was picked up and thrown a distance of about 500 yards and then deposited on the other side of the road. Speaking to some of their family down there, that was really tough to, deal with because the emotional side of it, obviously. But shot a ton of video down there. And ended up shooting video on 5 different tornadoes. But that event's never going to lead me to the day I die. I hope and pray that Chasercon never has another event like that. But the past is always an indicator of the future. If it's happened before, it could probably happen again. It probably will happen again. But that was April 13th in a very quick 15-minute nutshell. And with that, I will kick it to Chris.
Wow, that's a pretty eventful day. I know that's not only the physical part of the chasing, but the emotional part has got to be tough as well. I don't think we've got any questions from the YouTube chat. So let me go ahead and introduce our next speaker, our next chaser, Peter Forrester. He's a master's degree student at Virginia Tech, and he and I have been on at least one Hokie storm chase trip together, maybe more. I can't remember, Peter. But he is an avid storm chaser here in the Mid-Atlantic, owns his own company, the Nova Storm Chasing. He's also a nature photographer. So, if you want to follow him, his social media feed, he's got some pretty cool photography out there. So without taking any more of his time, let's toss it over to Peter and hear what he has to say about his favorite 2020 chase.
Thanks so much, Chris. And Chris Jackson, thanks for that awesome story. That's the sloppy chasing in the South that, we have the option to chase, but
Yes.
hopefully avoid it when we can. So
That's right. It's hard to pass up a backyard chase.
that's right. Yeah. So this was actually a backyard chase on my part. Very different kind of storm, though. This is kind of a mid-afternoon exciting event that looked amazing, but fortunately didn't cause much damage, didn't cause any injuries, any of that kind of thing. So this is the highlight of storm chasing for kind of what we target. And again, I'm Peter, Nova Storm Chasing. There are my links here. You can pull these up later if you'd like to check out my stuff. So this was a supercell in Virginia that, in my opinion, is Great Plains quality storm structure, something you don't see often around here, but it does happen occasionally. And very fortunately, I was on this particular storm. This was June 25th, 2020, and I operated out of Charlottesville, Virginia, which is where I live at the moment. Pandemic has moved me away from school. And Charlottesville has this little knack of attracting these big storms like this. And it's partially because of the terrain and the unobstructed flow that we get from the Atlantic and all that stuff. So these storms have happened before in Charlottesville. So I was in a good spot and was kind of looking at the setup. And it was really interesting because polar opposite of what Chris talked about, this was a marginal event, a 5% for hail and wind. And the Storm Prediction Center basically saw this last minute and said, sure, we'll put up a marginal risk and see what happens. A environment that supports low-end splitting storms capable of producing marginally severe hail and a couple strong wind gusts. Not the kind of thing you'd expect to say, oh man, we're going to have a crazy storm chase today. But the interesting part of this was there's a diffuse surface trough that will move slowly eastward. And this is kind of what we call lee troughing in the Appalachians. It's sometimes ahead of a cold front, ahead of a low pressure system. And these lee troughs act as forcing mechanisms for these more isolated storm modes. So round one in the early afternoon, 1 o'clock, 2 o'clock in the afternoon, was exactly what the SPC forecasted. It was small linear storms, gusty winds, a little bit of hail. You can see a nice Peleus cap on top of that cumulonimbus right there, indicating some really nice upward motion with your high Cape values. And then the picture over on the right side there is a little bit of a cell, kind of a little bit of shear and rotation there. You can see the kind of the rotating updraft in this early afternoon storms, but really nothing to write home about. I took this picture from my driveway and waved at it as it went by. So something very interesting that did happen though from these storms, they set up a series of outflow boundaries. And these boundaries just sitting there, a little boundary that storms can kind of latch onto later. And so they were visible on visible satellite, this little line of clouds oriented east to west, just north of Charlottesville. And the overall setup was decent too, 45, 50 knots of shear, 2000 cape. And again, this subtle trough that I talked about. So 4 o'clock go time. Aubrey, I got one of your tweets here. She was watching it on the Harrisonburg Skycam network, which is fantastic. I always like seeing the storms income from the west. So this storm cell was barely alive, kind of passing over Harrisonburg. It had a little bit of an updraft base, but not much. 5:30 p.m., storm had crossed the ridge, the Blue Ridge Mountains, and had survived. So I met up with my chase partner, Andrew Shearer, in the town of Ruckersville, which is about a 20-minute drive. 5:45 p.m., here we are in position in Ruckersville, and this storm was like barely operating. It has a little bit of an updraft, kind of looks like a cumulus cloud, like a clear air cumulus cloud, maybe a summer thunderstorm kind of a look. But this was the interesting part. It has a nice, crisp, and round-looking updraft base. And so it's kind of caught our attention, like, okay, maybe it's worth another 15-minute drive to see what this does down the road. 6:10 p.m., a little bit further east, and suddenly we can see it's got this striation structure. The long streaks kind of moving through the storm there, and you can see the nice hail core in the background. Like, okay, this actually might be rotating. It might be something, and it's looking a lot bigger now. It's looking a lot more healthy, and we get a lightning spike. So that's always a good sign when you're watching a storm like this kind of develop. A big lightning spike, it means it's kind of latching onto those parameters and starting to take off. 6:15 p.m. Suddenly we get this, we called it a wall cloud at the time, but in hindsight, this is actually something that is probably an RFD shelf. That's the rear flank downdraft. And you can see that clear air slot in the middle there kind of wrapping around the updraft of the storm and creating the shelf cloud. So another really good indicator that this storm is actually starting to rotate a little bit. So we kept driving, kept sticking with the storm, and 6:30 p.m. Now it started to get interesting. So this was in the town of Orange. And we, of course, the worst part of chasing is trying to get through the traffic lights, and the small towns or even the big cities, try to avoid the big cities. But we're sitting at a stoplight and look up at the updraft of this storm, and it's forming an updraft vault. And this is an area where the updraft, the mesocyclone of the storm, is starting to separate from the precipitation. So you know that the storm is tilted over. And you've got a really nice thick inflow band coming from the right side there. You can see the RFD shelf, or a kind of a marginal wall cloud there on the bottom. And then the upper right of this photograph, you can really see the updraft vault starting to form. And at this time, the storm was going off with lightning. You can see that the precipitation from the anvil is getting blown off to the north. It has some pretty nice rotation on radar. It's a far away from the radar dish, so it wasn't totally a clear picture of what was happening in the low levels of the storm, but still good velocities and a good looking storm. And I tweeted this out at the time. We're pretty confident at this point that it's a supercell. So I went ahead and said that, and you can see the striations and the RFD and all of those classic features you look for in a supercell. Moving on, this was 6:40 p.m., so about an hour after we hopped on the storm, and it's got that nice crisp updraft base and those rotational striations, and you can see the air rotating around the main mesocyclone there. And then we got through this interesting process of storm cycling, and this is one of the more complex things to explain when it comes to supercell characteristics, but a storm will go through several phases of rotation, and a storm, it's more like a family of mesocyclones, a family of updrafts that all develop and then dissipate, all while keeping the single storm cell alive. So what we were just looking at was a single crisp mesocyclone, but then as that RFD came in and wrapped around, it starts to turn into a shelf cloud. The RFD actually undercut the updraft a little bit, and makes it outflow dominant. And we call that a shelf cloud on the front side. But then as this cycle continues, a new rotation center, a new mesocyclone develops on the precipitation side of this updraft, and then you can get that into a new deep meso. So this is a picture of my friend Drew, who I was with, and the end of the shelf cloud, kind of the beginning of this new mesocyclone there. So this is looking to the south. We're right in the inflow notch of the storm. So looking to the south, obviously a shelf cloud. It's a really nice one for Virginia, but not what you look for in a supercell. But you look off to the north of the inflow notch, and suddenly you get this nice crisp vertical edge, and this is a new mesocyclone developing. And this was a shot just out of my car window, hence why it's blurry and dark and all that. But at this point, it was kind of like, oh, okay, this storm is getting its act back together. This is when the lightning started coming down, the positive lightning bolts striking in the clear air of the storm, and starts to make your senses tingle a little bit, and it gets exciting. 7:30 p.m. and for the next 15 minutes, this is some of the best structure I've ever seen in Virginia. Gigantic stacked mesocyclone here, and it's kind of eaten up that shelf cloud and absorbed it into the mesocyclone structure, and it looks just fantastic. So we're sitting in the inflow notch. At the time that I took this picture, there's lightning bolts dropping all around me, constant thunder. You can see the orange glow from the setting sun in the back there. And then even at the very bottom of that shelf cloud, you can kind of see where that wall cloud is. That's where the tightest rotation and where a tornado would develop. I know that the National Weather Service was considering a tornado warning at this point, but we were talking to them, noticed that the storm was a little bit elevated, not quite what you look for a tornado. So I think they made the wise decision to not pull a tornado warning on this storm. Continued about 5 minutes later at this same spot, and just fantastic. And you can kind of see the green glow in the back there. At this point, it was dropping 1.5 inches hail, like 70, 80 mile an hour winds and stuff. So we were sitting here in the inflow region. We don't want to get caught in that. So it's time to roll. It's time to get going. So like I said, this was shot out of my front windscreen, and you can see that the storm structure is just vertical. I'm looking up in this picture, and you can see that the houses, the telephone poles, and everything are just dwarfed by the size of this mesocyclone and shelf cloud that are coming at us from the west. And I got like 3 minutes to send a tweet out. So this is a quick panorama from my iPhone. Managed to tweet it out just in time. And you can see the green glow, but it's a blurry picture, and kind of gets the idea of just how exciting it was. And you can see our position there on radar, right in the hook echo, right in the inflow notch of the storm. So kind of perfect placement. 7:45 p.m. Suddenly we start going through one of these cycles again, and this giant mesocyclone starts transitioning more into a shelf cloud or an outflow based storm as the storm continues to cycle. So this is actually a raw photograph. I adjusted the exposure a little bit because it was a little bit dark and a little bit of the light, but the colors are not changed in this photograph. So it was a deep blue, deep turquoise blue, which indicates just the size and the depth of the moisture that's behind the shelf cloud, and indication of the hail. And then moving towards sunset, the sun went down right behind this shelf cloud. And this was approaching I-95 now, so we've been driving 60, 80, 100 miles staying on this same storm. And by this time, the mesocyclone had pretty much died. So this is a totally outflow dominant storm, but still top 3, top 4 shelf clouds I've seen in Virginia. So very, very impressive. So at this point, by the time we got to I-95, Drew and I decided to call the chase. It's getting dark. You're getting into the swamps, the lines and lines of tall pine trees and stuff. And we're like, we've already driven 100 miles with the storm. We might as well let it go. This is photographs from my good friend Roman Miller. He actually chased it down more towards Wakefield and east of I-95 for a little while. And you can really see the shelf cloud structure, and even see the top of the storm. So you can see the bottom and the top of the storm at the same time. And that's just a good indicator of how strong the shear was and how good those cape dynamics were. So a couple of notes about this storm setup. I was looking back through reanalysis, through mesoanalysis, and et cetera. Maximum supercell composite of 2. Not kind of what you expect for a setup like this. 2000 SB Cape, 40 knots of bulk shear, and really poor lapse rates along like 5 degrees Celsius in the mid levels. So that's enough for some supercells. And in the Great Plains, you know, you might get 1 or 2 good supercells out of that. But what made this one go crazy? And the point of all this is to say that the mesoscale or the smaller surface features have a huge impact on what storms do locally, just absolutely huge impact. That outflow boundary, the storm latched onto an outflow boundary and used moisture, the difference in moisture and shear and instability on either side of that outflow boundary, and it just exploded. And this happens from time to time in Virginia. And honestly, it's the primary way that we get these big storm setups. And there's a little bit of academic research about this, published literature and et cetera, but really not very much. This is one of the 2 or 3 examples that I found that talks about this Appalachian lee troughing and the kind of storms and how it subtly enhances storms in this kind of marginal setup. So that's what I got. Special thanks to Andrew Shearer, who chased with me and provided the radar images, and then my good friend Roman Miller, who helped me with the storm reanalysis and everything. So check out my Facebook pages, my website, my Twitter, and I will send that back to you. Thanks so much.
All right. Aubrey, do we have any questions?
Yes, we do have a question. So First in Weather wants to know, why is the Charlottesville terrain more favorable for supercell formation than other parts of the state?
So that is a fantastic question that unfortunately we don't have a solid answer to. The primary reason, I think, is the orientation of the Blue Ridge Mountains, because your predominant mid-level winds come from the west, so westerly winds, and the predominant surface winds in storm setups like this are from the south. So the Blue Ridge Mountains kind of force those winds to overlap right up against the mountain ridge along, it's not Charlottesville as much as it is the Route 29 corridor. So Danville to Lynchburg to Charlottesville to Warrenton. That area has this, the terrain forces the dynamics to work a little bit better together.
Right, and I would second that because I used to chase up in that area as well, and of course I chase in Southern Virginia now. And the Route 29 corridor is a pretty good approximation of the Lee Trough, where you get this little kink in the isobars that can cause storms to spin. Peter, one question I was going to have you expound on a little bit. You hinted at what chasers call greenage in a storm. That green-blue hue. Can you talk a little bit about what causes that?
Yeah, absolutely. So greenage is a good measure of how much liquid is in the storm. Kind of a way meteorologists like to talk about it is vertically integrated liquid, but it's a measure of how much water and how much ice is back in the storm. And the green is really a measure of sunlight that shines through the back of the storm. So you're more likely to get it kind of in the evening when the sunlight is more direct onto the back of the storm. And so it's just that sunlight passing through the ice and the moisture and getting filtered out so that you're only able to see those green wavelengths.
Thanks. So it's not just a matter of whether there's hail or a tornado. It's an optical phenomenon.
That's correct. Yeah.
Okay. Thanks, Peter. Appreciate that. Let me toss it back to Brent.
Very, very informative. I love hearing more about these specific events. And, the next speaker and chaser, I got to hear at a conference in Raleigh. And, I'm old and I don't remember the exact topic of it, but I do remember how passionate Matthew was about weather. And he was very, very young at the time. And I think you were still in high school, weren't you, Matthew?
Yep.
And so I remember hearing him speak at a weather conference, and he was still in high school speaking to all these meteorologists that some had been in the business for decades, and just very passionate. Went on to be a 2019 Harvard graduate of atmospheric sciences, a meteorologist with Capital Weather Gang. Many of you may follow them. also an avid storm chaser, which is why he's on talking with us today, and is also an educational consultant and teacher. So we're going to hear from Matthew Capucci to talk more about his experiences with chasing storms in and around the Mid-Atlantic. Matthew, we'll turn it over to you.
Hey, well, thanks so much. Yeah, it's been a pretty exciting year of storm chasing for me. I'm going to try to share my screen right now. In fact, earlier this year, I actually got sideswiped by an EF1 tornado in Bowie, Texas. So that was pretty exciting. But one of the starts of my year was actually chasing tornadoes during Hurricane Isaias. And so that pretty much wrote up the entire East Coast. We got 39 tornadoes out of this. And very atypically do you see tornadoes along the East Coast from tropical cyclones, never mind 3+ dozen of them. And one thing that really called my attention, 8 of them were significant tornadoes. So about 20% of them, we had 2 fatalities with one in Windsor, North Carolina. And that proved to be the strongest tropical cyclone-related tornado in the U.S. in 15 years. In addition, one of the tornadoes actually came ashore as a waterspout in Long Beach Island, New Jersey, with a 109-mile-per-hour wind gust measured by a weather station. I can't remember the last time we had a tornado directly hit a weather station on the East Coast. So a phenomenal event. It produced the longest track tornado in Delaware on record as well. And myself, Peter, Andrew Shearer were all out there in eastern Delmarva chasing. So one thing about Isaias, everybody on the East Coast got it. Tropical storm watches, warnings all up and down the coast, plentiful rainfall, but it actually started back in late July all the way off the coast of Africa. So it was one of the few really good main development region storms that we got this year in what's been largely a homegrown tropical cyclone season. Leading up to the 31st of July, it became a hurricane right after passing Hispaniola. And the interesting thing, we thought it was going to fall apart as soon as it crossed the Dominican, but in reality, you see, this is right before it crossed. What happened was the center reformed north of the island. The low-level center and the mid-level center kind of became detached. A new one formed north of the island, and that's when it actually became a hurricane again, eventually weakening towards Florida and then re-strengthening the night of, I believe, the 3rd into the 4th. And here you see it, looking pretty impressive. Lots of transverse banding. I think this was the night of the 2nd, actually. Transverse banding the northern side, great convective bursts overnight, gravity waves. And that's when we realized, oh, wait, this could be a pretty decent hurricane for some along the immediate coastline. So a lot of tornado warnings all up and down the coast. And the day before, about 10:44 in the morning, was when I accessed this model. It was on the 3rd of August. And that's when I thought, I haven't really seen something like this before on the East Coast associated with a tropical cyclone. And to see this plume of just a very narrow corridor of extremely high STP from the HRRR really called my attention. The NAM was spitting out numbers like that too. The Storm Prediction Center had a slight already, and we're actually going to upgrade to an enhanced. And it verified quite well when you see all the tornadoes up and down the East Coast. I want to focus first on this little cluster near the Carolinas border. That was on the night of the 3rd. And you can see right here, as early as 3 o'clock in the afternoon, SPC had a mesoscale discussion out. We had dew points in the upper 70s. Look at that, 78 right there in the Eastern Carolinas near the Outer Banks. And Wilmington issued their first tornado warning later that evening. Now, as the storm made landfall, you can see it has a very weak remnant eye wall wannabe. It was a Category 1 when it made landfall, 75-mile-per-hour winds. But notice already that kind of band of persistent supercells forming on the northern flank and really getting going as they made landfall. And the interesting thing, the bulk of them were less than about 30,000 feet tall. So most of the shear was concentrated in the lowest kilometer, 2 kilometers. And that's really what helped push this from an average event to an over-the-top event for the East Coast. And even in that remnant eye wall, you see very few tops over 30,000 feet. So it wasn't an overly powerful hurricane, but it was a very sheared storm, and that's what contributed to a significant burst of tornadoes. Take a look at this, 8, 9 different mesos coming in. This was around 8:45-ish p.m. on the 3rd. And you can see just everywhere, couplet after couplet after couplet. I think we had 7 or 8 tornadoes with this first batch as soon as the storm made landfall, one of which was an EF2, the bulk EF1s. And you can see them all plotted here, mainly south and west of Wilmington, between Wilmington and Myrtle Beach. But then we had this second batch overnight as Isaias moved further inland on the right side of the storm, and right front quadrant. That's a typical region we see for tropical cyclone-related tornadoes. And because this had moved inland at the time, you had a little bit more friction in what we call the Ekman layer near the surface, influenced by the roughness of the ground, and that caused the surface winds to slow down. But the winds right above can keep going, and as a result, we got a lot of shear, a lot of spin ups, and it proved to be a prolific tornado event. So again, here's that cluster I want to focus on. Southern Virginia Tidewater, Eastern North Carolina. And they had that mesoscale discussion out, helicity near 600 units, which ordinarily, if we were talking 100, 200, I'd be out there chasing, expect to see good storms. 600 is through the top. So amazing to see. I tweeted this around midnight that night. This was a model run for the next day, and the models captured this very well. We had that just persistent train of supercells coming in, flooding risk on the western side, some places in St. Mary's and Calvert counties near DC, saw about 10 inches of rain. And the models were also kind of alluding to the potential for a sting jet type feature on the backside. You see I highlighted in purple, that wraparound stinger where air that is moist is kind of evaporating as it's pushed downwards and into the dry air, causes winds and momentum to be pulled down to the surface and accelerate as they reach the ground with gusts over 80 miles per hour possible. And that's what the model was indicating would be the potential. This one, the HER, for example, had 92 mile per hour gusts over southern Delmarva. This didn't pan out over Delmarva, but it did over New York City, and they saw 80 mile per hour gusts. So again, here's that second batch of tornado warnings near midnight. Again, all over the map, just storm after storm. Look at all the couplets. And then in Windsor, North Carolina, they had a strong EF3 tornado that killed 2 people, hit a mobile home park, and this proved to be the strongest tropical cyclone-related tornado in 15 years since Rita back in 2005. On radar, reflectivity doesn't look all that impressive. You see one blob of red right there. And initially, it didn't look all that impressive on velocity either. We were about 5,000 feet elevation, so still decent coverage. It should look more impressive. But the thing you have to remember with tropical cyclone-related tornadoes, this is all within the lowest 1 kilometer, if that. It's an extremely shallow mechanism that produces these tornadoes. And that's part of the reason why we actually struggle to issue tornado warnings with few false alarm rates for tropical cyclone tornadoes, because all the couplets honestly look pretty cruddy for most of the time. And yet this couplet, which doesn't look all that overly impressive, wound up producing the most powerful tropical cyclone tornado in 15 years. So you kind of got to warn everything. In this case, Weather Service had a great warning well in advance of the storm. There was a little pixel with 81 miles per hour gate to gate at around 5,000 feet. And then notice there's kind of that secondary pixel over there at roughly 42 miles per hour gate to gate, just north of Windsor. And this actually wound up being about 600 yards wide, so about a quarter of a mile wide for the tornado. Huge for a tropical cyclone tornado. I'm wondering if there could have even been perhaps a secondary circulation, or more likely a satellite vortex wrapping around. I'm sure if it was daytime, perhaps we would have seen that, but this was in the middle of the night. But regardless, very scary situation there. Debris tossed up to about 25,000 feet with that tornado. And again, you see it right there. One thing I want to caution, whenever I chase tropical cyclone tornadoes, I don't use velocity all that much. Yes, I use it to look for broad rotation, but I'd much rather look for spectrum width. Spectrum width is a product we use with the radar that shows how chaotic the motion in pixels is. And when we have a lot of chaotic motions, meaning hydrometeors, rain, hail, whatever, moving in a lot of different directions in one pixel, that could be an indicator of rotation or a tight vortex. And we see that right there moving towards Windsor. Now, meanwhile, myself, Peter, Andrew, we are all over in Ocean City, New Jersey. That is, of course, to scale. I'm sorry, Ocean City, Maryland. This was around midnight, 1 in the morning. Most of the rain was off to our west, but we were waiting for that train of supercells to come in. 4 o'clock in the morning, we had some appetizer, little showers move through, but even the tiny puffy showers, you can see they're already spinning that wannabe couplet down to the south and east of West Ocean City. And the sounding that morning from Wallis Island around 7, 8 in the morning, that thing was loaded. Look how much shear there is, just both speed and directional. Near the ground, you have about 30, 35 miles an hour out of the southeast, but then just above the ground, you have 50, 60 knots from almost a due south. So a lot of turning of the winds in the lowest kilometer. And notice how low LCLs are, lifting condensation levels or cloud bases, meaning any storm that forms will be right above the ground, and it'll be a lot easier for that rotation to snake down. And you see the dew point and the temperature, these two lines in the sounding, are extremely close. So the air is saturated. The air is very juicy. So you're not going to be able to see all that much. I chase a lot in the plains. I've chased in Florida before. This is a very different game. And the cool thing is, just an aside, this was a hotel room we shared. I want to show you what happened when we opened the door, because we had one of the windows open and the pressure gradient inside the building was so strong that this was the result.
There we go. And this door normally goes right open, but look at the powerful suction
Like, I genuinely cannot very easily open this. So thanks to pressure gradient, it was very sucky inside. So anyway, this was around 7:13 in the morning. I was already working at this point because remember, this was, I think, a Monday or a Tuesday. I was working with the Washington Post and I was writing since about 5:36 in the morning. And around 7:10, I went, well, it's almost game time for us. I hadn't even left the hotel yet. And we got the tornado warning. I decided to drive a little farther east. And you can see multiple couplets. That first one near Snow Hill, I knew I couldn't get to in time. But then there was one near Newark and one near Berlin and eventually another one to the east. And I thought, okay, I'll go to Berlin. This thing was moving almost due north. And again, you see a lot of rotation. Tough to see exactly where that couplet would be, the best, most localized rotation. So, and the other cool thing about this, with these storms, they're so shallow, so tilted too in the extreme shear. Probably, I'd say maybe 20, 30 degrees or more of tilt. That look at the reflectivity at 7:55 a.m. and also at 7:55 a.m. near where the worst reflectivity was, the cloud tops were very shallow because the storm was so tilted, all the storm tops to the north. But on the red dot right there north of Berlin, and you can see the couplet is getting very close. And one thing I noticed, with these type of storms, you can't really rely on your senses. In other words, judging how much light there is. That's a pretty good indicator of how tall a storm is when you're on the plains. But in this case, because it was so sheared, it actually lightened up right before the meso hit. So it was really dark. We were in a rain core. All of a sudden, it got a little bit brighter. And then with that, it got very dark in the order of about 15 seconds. It reminded me of almost a solar eclipse and how quickly the darkness came in. And then look, between 7:57 and 8:01, that couplet moves about 4 miles and zoomed right overhead of me. So at first glance, I looked up and we had instantly 60, 70 mile per hour inflow move in. And that was pretty impressive because it was like this, like someone flipped on a switch and the clouds were maybe 150 feet above me. And you can actually see the discernible swirl very well as that meso passed overhead. And what ended up happening was right afterwards, I got on a north-south road and you can see the meso very well. There are some ground scraping elements that prove to be tornadoes, intermittently kind of a skipper, but it's... And so you can see on the right, that column.
Turn left onto Old Ocean City Boulevard.
So easier and more ragged to the north, left, and then come to see that just from the side. It's hardly a half mile to a mile away, so it was pretty close. And the other cool thing, you can see on spectrum width, nothing, something kind of interesting, and then boom, just to my north, when I see that, that's when the rotation really tightens up. Now, to my east, when I was going back to Ocean City, there was another area of well-defined spin. And that one was interesting too, because that produced a tornado as well. Oh God, that's a horrible screen save. Well, anyway, ignore that for a moment. That produced another tornado too, and I was on that one. That one, it was so tricky to see because this tornado didn't even look like a tornado. You'll see in the background, the meso, very clear base, and then you'll see these little tendrils almost reach down. It was like it didn't even have time. It was almost outrunning itself. And
good morning, gang. I want to show you what one of these tropical theater bags looks like because this rotation that just passed overhead, you can see a new area of spin moving towards us right now, and the rain picking up quite a bit. But in just the past 3 minutes, winds did a 180
Proceed to the route
as that rotation passed by, and you can see there are those.
It's kind of interesting because the rotation really did the winds did a 180 as that rotation passed overhead. So on the left, there's that first EF0 that I encountered, and then to the east, near the Glen Riddle Golf Club, there's the second EF0. Both were skippers. They were intermittent, but did produce a very visible swath of minor damage. So you see them both right there. Dover, Delaware got hit by a tornado later on, about an hour later, and then you can see that whole thing moving to the north, eventually into New England. And this just has to be one of the most remarkable radar frames I've seen on the East Coast. Where we were, it was clear by lunchtime as that dry slot worked through. But the dry slot, as it pushed north, helped tighten up that sting jet feature that I mentioned earlier on, the wraparound. You can see right here, dry air and then a bit of a stinger. That hit New York City with 70 to 80 mile per hour wind gusts, clocked both at JFK, LaGuardia, and into New England with very strong gusts as well. Now, on my way home, I passed, you see that little circled one, that is in Mardella, Maryland. That was a brief EF2 that was on the ground for maybe a half mile, if that. And I went and I surveyed the damage, met a very nice lady named Joy Mitchell. She said she'd been looking out her back porch at the time. It was still as could be outside. and it actually touched down in her backyard. And this thing, it was like on and off, in and out, whether or not you were in the damage. It just suddenly touched down in her backyard. The corn over there, you see, the corn back there, the power lines, undisturbed, other than a tiny swath, maybe 30 feet wide, of the corn that was just flattened all at once. It was a very narrow funnel. EF1 tornado damage to a trailer. This looks like maybe EF0, EF1, but then look, this whole thing was pushed off the foundation. And the only thing that stopped her from going into the street was that she had this anchor cable. And then again, high-end EF1, low-end EF2 damage there. This wrapped up as EF0 to EF1 damage further on, and you can see the vegetation damage. Very narrow little thing. And it's just so weird to see corn on either side undisturbed. Anyway, really appreciate you taking time to watch. And thank you again to our conference organizers for this. You know, a lot of conferences all across the country have been canceled, but weather folks are very dedicated. So a huge thanks to the folks who made this happen and who are allowing us this opportunity to speak today. Follow me on Facebook, Twitter, and of course, get our content in capitalweathergang.com. Thank you.
Well, that was awesome. I mean, I could listen to that all day, but I know we wanted to give time to see if there are any questions. Anything that you come across, Aubrey?
No, I don't see any questions in the chat. All three of our presenters, those were fantastic presentations. So thank you all for chasing, for staying safe, doing what you do, and also putting things together for us so we can see exactly some of those interesting chases that you've done.
Yeah, and anybody who's ever chased tropically induced tornadoes can relate to what Matthew was talking about, is how fast things happen, how low top the storms are, and how you really can't trust the radar, you know, as much as you need to watch with your eyeballs. Peter knows that a couple of the Hokie storm chases, I've kind of twisted the students' arms to stop looking at your phone. The storm's out the window.
Chris,
So,
we do have one question that just came in.
Okay.
Michael wants to know, Matthew, your opinion on bottom-up tornado genesis.
You know, that is a phenomenal question. To be honest, I am increasingly sold on that. I having been out there in Tornado Alley many times, especially with tropical tornadoes, I imagine it's different. But having been out there many times, it just seems as though, you know, if it were exclusively top down, one would think you'd first start getting damage gradually as the circulation starts to build down from the top. In reality, as we just saw with the storm I showed a moment ago in Mardell, Maryland, for example, so often we see it happen all at once, as though there's this vortex near the ground that is wide and then all of a sudden gets pulled up and stretched, and suddenly we get the damage kind of on like this. And so I do lend an increasing amount of credence to the theory of bottom-up tornado genesis. I'd like to see where that research goes in the future. I think we need denser observations, of course, but that's a limitation across the entirety of meteorology. So this is nothing new. But yeah, I look forward to seeing where those researchers take the work in the future.
yeah, that's a great question and an answer as well. I've wondered about the same thing, having chased both here in the Mid-Atlantic and out west. I've seen a number of funnels here that never resulted in any damage. So how do you reconcile that with, you know, a ground circulation starting first? That's something I kind of scratched my head on. So Matthew's right. We need a lot more data on both those. So any other questions from our panel? Anybody else want to ask a question of any of our speakers?
Chris, I actually had a question for you. So when you encountered the merging tornadoes, which seemed like a generational type event east of the Appalachians, so kudos to you for finding that. But when you encountered those, how did you balance the fact that there were two tornadoes very nearby, and then I looked at the radar at one point, 4 tornadoes within, it looked like 15 miles, and it seemed like all your escape options, it was like a game of meteorological whack-a-mole. How did you manage that and navigating in poor territory simultaneously?
The biggest thing was, Matthew, was just understanding my chase terrain and knowing. I guess I went into that knowing good and well. I only had one chance to even get close to anything safely, and I was coming in from behind it. If I could find a good road that I could just fall in and kind of parallel the storm as it crosses the road, even though it might not be parallel and perfect. And it just so happened to work out. I had that one road. After that storm crossed the road in front of me, and obviously all the pine trees and stuff on the road, there was no way I could, continue the chase. And it just happened to luck out to where that tornado was on the top of that line, that comma head on that QLCS, where all the tornadoes were south of where I was. So it just kind of lucked out. I was on the northernmost tornado. You know, had I been 5 miles south, that might have been a different ball game with that second tornado. I mean, I never thought in a million years there would be two EF3s on the ground simultaneously within 5 miles of each other, you know, 20 or 45 minutes from my house, but it happened.
Jeez. And yeah, those QLCS ones can be nasty. I was chasing in Burke Burnett, Texas back on May 22nd, and that was the day that we got 6-inch hail in that town, setting the Texas state record. And
I was on that same storm.
Oh, yeah.
Yeah.
And I was kind of mad at myself because I dipped south for the second storm to produce a tornado near Bellevue a little bit late. And so I missed it by about 10, 15 minutes. Still got pretty good structure. And
I caught the rope out on it.
Sorry?
I caught the rope out on that tornado.
Oh, lucky. I'm jealous.
Yeah, I got a little bit of video of it, but yeah, the hail down there in Bowie, Texas that night, that was one of the most crazy events I've ever seen.
Oh,
you know, personally, out chasing.
Oh, so did you get hit by it?
No, we were just south of Bowie. Was that like 281 or whatever it is that goes down toward like Fort Worth from Bowie? You know, we stayed about 5 miles out of town and just watched all the power flashes continue nonstop for like 45 minutes. And then we went back into town. Of course, town's, you know, got 3-4 feet of water in places, and not even to mention, we went down like 10 city blocks, and like everything is just either, you know, major damage or destroyed. And I
was there for it, and I got clipped by the tornado, which was kind of interesting because what had happened, I kind of called it for the day, and I started driving east. And like you mentioned, the QLCS earlier on, there were 3 circulations all right next to each other. And my hotel had been farther north, about 80 miles north, and I had to get north. The only intersection was in Bowie. So I thought, you know, I can either sit in town, ride out whatever comes through, or I can risk being on the road for it, going north-south. None of the options seemed appealing. So I wound up sitting in town. And it was interesting because the storm was so tilted that got the heavy rain, got whatever. It looked on radars as the circulation had passed overhead. In reality, I held my position for a little while. And that's when all of a sudden the wind went dead. I saw a power flash from about maybe a mile away. And what was interesting was that the fog rolled in very quickly. And that fog turned out to be the edge of the condensate from the tornado. Seemed to be kind of a rather diffuse wide tornado. And then with that, I got gusty about 100 miles an hour, pulled to the side of the road, hunkered down out there on the side of a brick wall. And it was amazing. Got good video too, but you have to do things safely, of course, so folks don't try that at home. But it was a memorable experience.
Yeah, that night was crazy. I'll join in you with that experience for sure.
Hey, Chris White. Hey, I actually have a question, just a real quick question for Peter. So Peter, you know, a lot of folks that know you and follow you have seen your photographs of storms. 3 quick tips without going, you know, really into detail. Give folks 3 quick tips for photographing severe weather and storms, whether it be safety, whether it be, you know, what you would do to get get in the right spot. What are 3 things that you would advise people to photograph a really good storm?
Oh man, that's a great question. It's really hard to narrow it down to 3. I would say number 1, understand the storm structure and position. So understand what you're looking at in the storm, where you are based on radar. If you're on the north side of the storm and there's nothing but stratoform between you and the interesting part, you're not going to get a good picture. So you got to position in the right place. Number 2, I'd say have the right gear and be prepared to invest a little bit in that correct gear. So iPhone, it's going to cut it if you want to post on Twitter, but if you want to get the really high quality photographs and be able to edit them and everything, invest in some gear, an entry level DSLR camera, a wide angle lens, that kind of stuff. It'll run you a few $100, but it's totally worth it. And then 3rd, I would say, spend the time to learn editing. A lot of what I do is editing my pictures, making sure the color balance is correct, making sure the exposure and everything is correct. And that is really the difference between an iPhone visual, which is just you snap whatever you see, and the more artistic and deep side of photography. So I'd say those 3 things as a super surface level. And I'm happy to talk more about those on social media or whatever with anyone who wants to chat.
Very good. Thank you, guys.
Yes, very much. And this is why we could continue on talking for hours. And this is why when you get a bunch of chasers in a room together, it's a lot better than being on a Zoom call. So hopefully next year we'll be back in the room together. So Brent, do you want to kind of close things up for us?
Sorry about that. I got multiple screens going on. Let me unmute myself. But first off, I want to thank everybody for joining today. For those of you that are joining each week, thank you so much. We have seen you. And a special thanks to our chasers today who have taken their time to put these great presentations together. I always love watching these because I've been doing this for a long time and I learned something new from each one of you because you get out there and you experience things. Each storm is going to be different. So thank you so much for again coming out and being part of this this event. So we certainly appreciate it. Of course, Chris Jackson, you heard from Peter Forrester, and then of course Matthew Capucci as well. So we had past weeks. If you wanted to check out past week's presentations, they are on the YouTube channel. So all you have to do is go back to the YouTube channel and check them out. We had some great presenters presented by, first off, Dr. Jeff Halverson. We had the first week, the Pennsylvania derecho of 2020, a big year for derechos. There were lots of them this year, and he talked about that. Jeff Orrock from the National Weather Service in Wakefield, a great discussion on Halloween. He was talking about the tornado outbreak in Virginia and in North Carolina, some really interesting perspective and great visuals on how the Doppler radar sees some of these storms. So really, really good. That was presented by NBC 12 in Richmond. And then we also had Aubrey Urbanowitz, who presented Karen Kasiba with the Center for Severe Weather Research, talked about the spinning Doppler radar on wheels. And this is something that you see a lot of times in the movies or on pictures, but you may have no idea what they do. Karen did an awesome job of explaining that and showing how important these Doppler on wheels are to being able to give us weather information, vital weather information that we need. So 3 great weather presentations. And then of course, this week's presentation where we had our storm chasers. And Chris, I know that you are hoping, while this went well, that next year we can get back in person, right?
Yes, fingers crossed that we'll be able to meet in person next year, and I'll be looking to secure the same venue we had in 2018 and 2019, which was the Science Museum of Virginia in Richmond, and we'll put out some more information in a little bit. Probably after the first of the year, once we get more a handle on dates and times and how things are going. But we'll certainly, if you stay tuned to the sites, websites, and social media you see there, you'll see some information come out on that. And the other thing to keep in mind is we have, in not too many months, we have the severe season starting again here in the Mid-Atlantic, usually about mid-March and later. So keep that in mind, and maybe hearing some more about that too. We'll talk about that offline and get back to you guys. So thanks for joining us. Thank you for our speakers today and for all of our speakers. And boy, it's just been a lot of fun. So look forward to seeing you next year.
All right, our stream.